All right, welcome. Today, we're going on a bit of a secret mission. We're going to learn the real secret language of computers. And no, I'm not talking about Python or Java. I'm talking about something way, way more fundamental. We're going to find out.
Have you ever really stopped to think about this? You hit the A key on your keyboard, and somehow this machine, which, by the way, only understands numbers, knows you mean the first letter of the alphabet. How does it know you're not trying to type a cat emoji or something?
Well, it's all because your computer is using a secret code. Yep, deep down, it's basically a code-breaking machine. Think of it like a universal decoder ring that translates every single thing you type into a number it can actually process. And you know what? Today, we're going to crack that code together.
All right, Codebreaker, welcome to your first mission. We're about to pull back the curtain on the secret language, this system, that honestly makes everything we do on computers possible.
So this secret code has a name, ASCII. Now that stands for American Standard Code for Information Interchange, which is a total mouthful, I know. You can just think of it as the official codebook for your computer. It's basically a big list that gives a unique number to every letter, every symbol, everything.
Okay, so right now you're probably thinking, oh great, do I have to memorize a giant table with 256 different values? And the good news is, no, absolutely not. The real trick here, the real secret, isn't about memorizing a bunch of numbers. It's all about learning a few super simple patterns.
So let's start with the easiest part of the code, just to get our feet wet and build some confidence. We're going to tackle the numbers first. This is where the pattern is just super obvious. Okay, so take a look. Now your first instinct might be that the character 0 would have a value of, well, 0. But nope, its code is actually 48, and from there it's just a simple count up. 1 is 49, 2 is 50, and so on. You see it, right? The pattern is already starting to show itself.
So here's the key takeaway. The only thing you really need to remember is that 0 starts at 48. That's it. Because once you know that, you can find the ASCII value for any digit. You just add the number to 48. So if you want to find 9, easy. It's just 48 plus 9, which is 57. Simple, right?
Okay, numbers are down. Piece of cake. Next up, the alphabet. Now, this might look a little more complicated, but trust me, there is this awesome little trick that connects the uppercase and lowercase letters, and it makes the whole thing surprisingly easy. So, just like we saw with the numbers, the alphabet has a starting point, an anchor. And for the uppercase letters, our journey begins with capital A at the ASCII value of 65. From there, it's the same deal. B is 66, C is 67, and it just keeps on counting all the way to Z. Okay, this right here is the first major key for our Codebreaker toolkit. If you're going to remember one thing from this section, make it this. Uppercase A is 65. Just lock that away. Because if you know that one fact, you can figure out any other uppercase letter just by counting up. But what about the lowercase letters? Well, they have their own starting point too. Lowercase a starts way up at 97. And at first glance, you might think it's a totally separate system. But is it really? There's a hidden connection between these two numbers. And here it is, the magic number. The key that unlocks the entire alphabet is 32. And this isn't just some random number I pulled out of a hat. 32 is the exact distance between any uppercase letter and its lowercase buddy in the ASCII table.
Check this out. This is how it works. You take the value for uppercase A. We know that's 65, right? Now, just add 32. What do you get? 97. That's the exact value for lowercase a. And this works for every single letter. B is 66, so B has to be 66 plus 32, which is 98. It's a perfect, elegant system.
Okay, so everything we've talked about so far are characters you can actually see on the screen. But what about the ones you can't see? I'm talking about things like the Enter key, or Tab, or even Backspace, where your computer uses ASCII for those too. These are the invisible characters. Just think about it for a sec. You press A, you see an A. Simple. But you press the Tab key, and what do you see? Just space, a gap. But to the computer, it sees both of them as just numbers. To the computer, A is 65, and that invisible Tab character is 9. It doesn't care if you can see it or not. So it turns out, the very first 32 values in the ASCII table, from 0 all the way to 31, are set aside for these special control characters. They don't draw anything on the screen. Instead, they give the computer commands. Things like start a new line, which is what Enter does, or move the cursor over a bit, which is Tab.
And here's a cool little tip for any of you who code. You can actually see these invisible characters. If you use a text editor like VS Code, just pop into your settings and search for a setting called Render Whitespace. If you change that to all, boom. Suddenly you'll see little symbols for every single space and tab. It's a really neat way to make the invisible visible.
All right, that was a lot, I know. So let's take a second and put it all together. Let's assemble our official Codebreakers toolkit. These are the only things you really need to take away from all this. Seriously, forget about that huge table with 256 different codes. You don't need it. All you really need to remember are these 3 key anchor values. If you know that 0 is 48, capital A is 65, and lowercase a is 97, you basically have the foundation to figure out almost anything else. And to go along with those anchors, here are your code-breaking rules. Just remember the patterns, right? Numbers, they start at 48. Uppercase A starts at 65. And lowercase, that's just the uppercase version plus our magic number 32. That's the whole system right there.
And that's really it. You've got it. With just those few anchors and a couple of simple rules, you now understand the fundamental language your computer uses for text. You've officially cracked the code. Mission accomplished.
But I do have one last question for you. A little food for thought. ASCII is the American standard code, right? It was built for English. So, how in the world do our computers handle every other language? How do they do Chinese characters or Arabic script or, every emoji you've ever sent? Well, that's a whole other secret code and a mission for another day.